tactile switch. Getting my point? This is also tactile. They are tactile switches because when you press, you will get a sound. Okay, they are tactile switches. Okay, this RB0 to RB1, RB2, RB3, RB5 are different arrangement. This is different arrangement. Okay, 1, 2, 3, 4. This is a different arrangement. Okay, so before going for arrangement, let us just understand how to interface a switch with the microcontroller, how to detect if the switch is pressed or not. That we'll understand, then we'll come back to the multiple switches. Okay, so here what I have done is we just understood the introduction. Like, switches, they're nothing but they provide a simple and cheap interface. Example, if you compare with a display or a screen touch. Okay, touch screen. Okay, touch screen is what? It is complex and it is costly. Because touch screen display, if you go, you have to pay 6,000 or 7,000. Switches will come in 10 rupees and 15 rupees. Okay, so switches provide a simple interface and cheap interface. They come in different shapes and sizes. Okay, so this is about what? The switches. Introduction, like why switches, what are switches. Okay, next what we are going to see is, circuit. Means how to interface a switch to the microcontroller. How to interface a switch to the microcontroller. Yeah, switches. We are done with the introduction. We are done with what? Introduction, just application, where it is used and why it is used. That much only we saw as a part of introduction. Okay. Next what we are having is circuit on a board. Okay, or interface. Next what we are having is nothing but interface. Interface means what? How a switch can be connected to a microcontroller. How a switch can be connected to a microcontroller. So here what I will do is, interface means what? Connection. Okay, so here what I will do, I will take a microcontroller. Okay, I already told you, if you want to interface anything to a microcontroller, that is connected through what? IO pin. Okay, a pin which belongs to a IO port. Okay, so here I have a microcontroller. Then here we have a pin of the microcontroller. Okay, so the pin, what we have to do is we can interface a switch. So we can understand how a switch can be interfaced to a microcontroller. Okay, so what will happen here? Okay, so I am taking here switch. Okay, so here one pin is the IO pin of a microcontroller. Through this pin only you can interface a switch to a microcontroller. Okay, so what I'm doing, one end I'm connecting to the pin, I'm connecting to the switch, another end of the switch to the ground I'm connecting here. Here we have switch. And on this pin, what will happen? We can read the values. What is the state of the pin? We can read the values. Okay. Say on pin, if the pin gets connected, it depends upon what is the voltage on the pin. Okay, if pin gets connected to a positive voltage, if a pin gets connected to a positive voltage like positive 5 volt, we call that value as 1. We call that value as what? 1. When pin gets connected to a positive 5 volt, we read the value as what? 1. Suppose if the pin gets connected to ground, then we read that value as 0. We read that value as what? 0. Okay, if the pin gets connected to positive 5 volt, okay, we call, what are the value we are reading on the pin is 1. If the pin gets connected to ground, then what the value we read on the pin is 0. What is the value we are reading on the pin will be what? 0. Okay, now coming to here. Okay, so now when the switch is pressed, okay, assume the switch is pressed. If the switch is pressed, okay, where the pin gets connected to? If the switch is pressed, where the pin gets connected to? What voltage it gets connected to? If the switch is pressed. Yeah, here what's happening? Pin is getting connected to ground. So what is the value on the pin when the switch is pressed? What's the value on the pin when the switch is pressed? We can call it as what? 0. We can call it as what? 0. Yeah, when the switch is pressed. Okay. Here what is happening when the switch is pressed? Okay. When the switch is pressed, what will happen here? Okay. It's getting connected to ground. So when it gets connected to ground, we can call that the value on the pin is what? 0. When the switch is pressed. What happens when the switch is released? What will be the value on the pin when the switch is released? Okay. When it is released, right? Okay. When the switch is released. Yeah, when switch is released, what is happening here? It's not connecting to 5 volt also, it's not connecting to ground also. It's not connecting to 5. See, one, if the positive 5 volt is there. Here, what is happening? 5 volt is missing. 5 volt is what? Missing. So we have to provide that 5 volt. Okay. Here we'll be having what? 5 volt. Okay. So what is happening when the switch is released? Pin gets connected to what? 5 volt. Okay. Switch gets connected to what? 5 volt. When released, it gets connected to 5 volt. So value on the pin gets connected to 5 volt. The value on the pin will be what? 1. We can read the value on the pin as what? 1. Getting my point? When released, it will be 1. When pressed, it will be 0. Yeah. And when you press, what will happen? There will be short circuit between 5 volt, okay, and ground. There will be short circuit between ground and, okay, 5 volt. So to avoid that short circuit, what we have to do is we have to provide here what? A resistor. We have to provide here what? A resistor. Yeah. So when released, what will happen here? Okay. When released, the pin gets connected to 5 volt. When pressed, the pin gets connected to ground. So when released, the value on the pin is 1. Okay, when pressed, the value on the pin is 0. So this is how we can detect whether switch is pressed or not. By reading the value on the pin, we can detect whether the switch is pressed or not. Okay, by reading the value on the pin, we can detect whether the switch is pressed or not. This is a one way of connecting a switch to the microcontroller. This is a one way of connecting a switch to the microcontroller. This is called pull-up circuit. Pull-up circuit. This is called pull-up circuit. Okay. There is one more way of connecting a switch to the microcontroller, that is called pull down. Okay. Why this is called pull up means when the switch is released, okay, what's happening? Pin is pulled up to the VDD. It's pulled up to the 5 volt. It is pulled up and connected to 5 volt by default. By default, pin is connecting to the 5 volt. So we call it as pull up. Okay. Next, we are having pull down. Pull down means here by default, okay, a pin will be pulled down to the ground. It will be pulled down to the ground. Okay, then here we will be having a switch. VDD, switch, ground, not VDD. Positive 5 volt. Yeah. So this is one way of connecting, okay, to the switch to the microcontroller. Again, there will be short circuit. So to avoid short circuit, we have to add a resistor. Then also one more resistor here. To avoid the, okay, sudden flow of current into the pin. To provide a sudden flow of current into the pin, we have to add a resistor to limit the current. To limit the current into the pin, we are adding a resistor. To avoid a short circuit, we'll add a resistor. Okay, to avoid short circuit, when the switch is pressed, there is a sudden connection between 5 volt and ground. That is called short circuit. To avoid short circuit, one resistor. To avoid, okay, sudden flow of current into the pin, which may damage the pin, one more resistor. Okay. Now we'll try to understand what will be the value on the pin in this case. Yeah. Now what will happen when the switch is, okay, released? See, when the switch is released in this case, where the pin gets connected to? When the switch is released. When the switch is released, pin gets connected to here ground. You can see it's getting connected to what? Ground. So value on this pin will be what? Okay, 0. Value on the pin will be what? 0 when released. When you press the switch, what will happen means, okay, when the switch is pressed, it gets connected to what? Positive volt. Okay, positive 5 volt. So value on that pin will be what? 1. Value on that pin will be what? 1 when pressed. Okay, this is called pull down circuit. Pull down circuit. Okay, there are two ways of connecting a switch to the microcontroller. One is pull up, one is pull down. Pull up, what will happen means by default pin gets connected to 5 volt. Pull down, by default pin gets connected to ground. That's how you differentiate it. In a pull up circuit, when the switch is released, pin gets connected to positive 5 volt. Value on the pin will be 1. When the switch is pressed, okay, okay, the pin gets connected to ground. The value on the pin will be 0. This is pull up circuit. This is called what? Pull up circuit. In pull down, okay, when the switch is released, pin gets connected to ground. So value on the pin will be 0. When pressed, pin gets connected to 5 volt. What? 5 volt. So the value on the pin will be 1. The value on the pin will be what? 1. Okay. Till here things are clear. The two ways of interfacing the switch and what will be the value on the pin when the switch is pressed and what is the value on the pin when the switch is released. Is this clear till here? Hello? Okay, everyone, till here things are clear. I'm waiting for your response. I got response from only Mitra. Others, Sai, Shankar, okay. Other people in the session. People who are joining through YouTube, okay, please try to join in GoToMeeting as well, because if you are joining in YouTube, I cannot get your responses. People in YouTube, please also respond in GoToMeeting app. Otherwise, I'm not getting any responses from you, because most of them people are joining through YouTube. And how will I understand that you understood the concept or not? Okay, fine. We'll proceed further. Now what I will do, just I showed you like two ways. On your board, how it is connected, that we'll try to understand. So on your board, how it is connected, and to which pin it is connected. How it is connected and to which pin it is connected. Okay, see, connected. Okay, that we'll try to understand now. How it is connected and to which pin it is connected. Okay, if you see here we have so many switches. So what we will do is just try to understand only RB0 switch. Means we'll just try to program this switch first. Okay, remaining we'll see later. We'll see only RB0 switch. How it is connected, which pin it is connected, that we will see. Okay. And here RB0 to RA5 is there, right? They are called digital keypad. This way of connection is called digital keypad. This 1, 2, 3, 4, 5, 6, 7, 8, 9, star, 0 and hash, they are called matrix keypad. They are called what? Matrix keypad. Matrix keypad we'll see, understand later. Now whatever I am teaching you is a digital keypad. The connection and how to detect whether switch is pressed or not, that is digital keypad. Matrix keypad we'll understand later. So going to the digital keypad now. Going to the digital keypad, we'll understand only the RB0 switch. We'll understand only the RB0 switch. So for that, in order to understand the connections, what I have to refer? In order to understand the connections, what I have to refer? Schematics. I have to refer what? Schematics. Okay, so now I'll go to the schematics. I'm opening the board schematic. In the board schematic, I'll open the switches. Where are my switches? Here are the switches. Yeah, RB0, here is the switch. So if you see here, first we'll understand only RB0 switch. You can see this is a switch. Okay, switch 19, the number is, this is a switch. And you can see here RB0 on the other end is connected to resistor and 5 volt also. So altogether I can draw it like this. I can just draw this RB0 is there, right? It is getting connected to a resistor and a plus 5 volt. I'm combining the circuits. You can see it's connected to a resistor and a 5 volt and a switch also. So together I draw him like this. I draw them like this. Okay, I can draw it here also. Okay, whatever is there in this schematic, I'm redrawing it here. We have microcontroller on the RB0 pin. Okay, this is RB0 pin. There is a switch connecting. Okay, switch is connecting to the ground. Other end of the pin is getting connected to a resistor and a 5 volt. RB0 pin name is RB0. Here we have a switch. So can you tell me what type of circuit it is, pull up or pull down? On your board, okay, we have a switch, this switch. Okay, this switch, I just opened the schematic and saw the connections, and connections are like this. Microcontroller, RB0 pin. This RB0 pin belongs to which port? IO port, which port? Port B. Port B is having how many pins? We are having 8 pins. Yesterday we have seen this. RB7, 6, 5, 4, 3, 2, 1 and RB0. RB0 to RB7. Here we have a resistor, here we have a switch. Yeah, so tell me what type of circuit is this? If you compare, okay, here we have pull-up circuit, here we have pull-down circuit. What it will resemble like? This here we are having here. What it will resemble like? Do we have a pull-up circuit or do we have a pull-down circuit here on our board? We have a switch connecting to RB0 pin, we have a resistor, we have a 5 volt. So switch is connecting to RB0 pin, that we understood. Okay, how it is connected? Is it a pull up or pull down? If you check here, compare here. It's a pull up or pull down? Yes, it's a pull up circuit. Okay, it's a pull up circuit. Okay, so what is happening here? We have a switch which is connecting to RB0 pin and it's a pull up circuit. Since it's a pull up circuit, what will be the value on RB0 pin? What will be the value on the RB0 pin when the switch is pressed or when the switch is released? Okay, so when the switch is released, the value on the pin will be what? 1 when released. Okay, when pressed, when pressed, it will be 0. When pressed it will be 0, when released it will be 1. Okay, this is our switch. Okay, this is our switch. Okay, then next what we are going to understand now, what we understood is we covered what? Introduction. We covered introduction about the switches, types of switches. We are using tactile switch, okay, applications, and why we are using it. Introduction done. Then interfacing means how a switch can be connected to a microcontroller. That is done. And the circuit on our board. On our board, how it is connected and where it is connected. That is done. Okay. Next topic is detection of the switch. Detection of the switch. Detection of the switch. Okay, detection of the switch is nothing but to detect whether the switch is pressed or not. Okay, so here we are having two detection methods. Okay, one is level triggering, okay, and one more is edge triggering, or we can tell it as triggering method also, detection of the switch or triggering. So what do you mean by triggering? What do you mean by triggering? Yeah, what do you mean by triggering? Generally, triggering nothing but initiate or to start something, to trigger something, to initiate something. Okay, here we are having two triggering methods. Okay, one is edge triggering. Edge triggering. One more is level triggering. Okay, edge triggering. One more is what? Level triggering. Okay, what is this edge triggering or level triggering? Okay, edge triggering is nothing but to trigger an event. Okay, to trigger an event, to trigger the event based on the value. To trigger the event based on the value. Okay, level triggering is to trigger the event, to trigger the event based on the change in the value. Based on change in the value. Okay, edge triggering is to trigger the event based on the value. Level triggering is to trigger the event based on the, okay, sorry, here, 1 minute. Yeah, this is edge triggering based on the change in the value. This is, okay, based on the value. Okay, so what I will do is to make you understand this. Okay, I know by knowing this definition, just putting this definition across, you'll not understand what is level triggering or edge triggering. Okay, to make you understand, I'll draw the waveform and as well as I'll give you one example. So what you will do means we will try to draw the waveform based on the value on this RB0 pin when the switch is pressed and when the switch is released. Okay. Suppose if I draw it like this, I'll take here, okay, the time axis waveform, and this is voltage axis. In voltage axis, this one let it be 5 volt, this one let it be 0 volt. Okay, so when the switch is released, the value on the pin will be what? Okay, 5 volt, correct? The pin gets connected to 5 volt. When pressed, it gets connected to what? 0 volt. So I'm just drawing the waveform based on the value when the switch is pressed and released. Okay, this is the value on the pin when the switch is, okay, released. This is the value on the pin when the switch is pressed. This is when released. This is when pressed. Okay, when released, value will be 5 volt. When pressed, the value will be 0 volt. Okay, fine. Yeah. So now if you are, okay, triggering the event based on the value, okay, if you're triggering the event based on whether it is 5 volt or a 0 volt or it's 1 or it is 0, then we call it as level triggering. If you're triggering the event based on change in the value, when the value changes from 1 to 0 or 0 to 1 or 1 to 0, it's called as what? Level triggering. Okay, let me take one example for this one. So everyone, have you operated TV remote? Have you operated TV remote anytime? Have you operated TV remote anytime? Yes. If you have operated TV remote, if you operated TV remote, what will happen when the, okay, switch is released? Assume the TV remote is also pull-up circuit. Okay, when the switch is released, the value will be what? 1. When the switch is released, the value will be what? 1. Okay, so I'll take here example of two things. The volume button. Example here, I'll be taking the example of volume button. I'll take here example of what? Volume button. So what will happen to the volume button when the switch is released? Okay, we are not doing anything. We are not doing anything. So assume it is also pull up. So value on the pin will be what? 1 when the switch is released. Now, when the switch is pressed, what will happen? The value will be 0. Okay, when the switch is pressed, what will happen? What is the task? When the switch is pressed, what are you supposed to do? When released, it will be 1. When pressed, what will happen? Yeah, when a switch is pressed, what will happen? The volume increases, correct? How long the volume increases? Only one time or continuously? So when you press the switch, volume increases continuously as long as you're pressing the switch. As long as you're pressing the switch, the volume keeps on increasing. Okay, once you release, what will happen? It will stop increasing. It will stop increasing. Correct? When you release the switch, what will happen? It will stop increasing. When you press the switch, it keeps on increasing. When you release, it will stop increasing. Yeah, so it keeps on increasing continuously. It keeps on increasing, correct? So this will happen as long as you're pressing the switch. As long as you're pressing the switch, it keeps on increasing. This is what level triggering. This is what level triggering. The task keeps on happening. Task keeps on happening. Okay, increase volume, increase volume. Once you release, it will stop. Again, if you press, it will continuously increase. How long it will increase? As long as you're pressing the switch, it keeps on increasing. Okay. Now come to TV power button, the on and off button. Okay, what is the task here? Task is to turn on the TV or off the TV. Okay, either on the TV or off the TV. Okay, here task was what? To increase the volume. Task was what? Okay, increase the volume. And how long the volume increases? As long as you are pressing the switch. Huh. But what happens to the power button? Okay, when released, nothing will happen. When released, nothing will happen. Okay, when you press the switch, when you press the switch, okay, and if you're pressing continuously, okay, will the TV become on off, on off, on off, or only just turn on? If press the switch continuous means not like pressing, releasing, releasing, pressing. You hold the switch. You press the switch and you're holding it. Okay, you are pressing the switch and holding it. Okay, so what will happen? As long as you press the switch, will the TV become on off, on off, on off, or only it will turn on one time? It will just turn on one time, or it will become on off, on off, on off. Even though you press it for long time, even though you press it for long time, one time only just TV will turn on. One time only just TV will turn on. Okay, once you release, it will go back to one. Again, you press, what will happen? Again, you press, it will, what will happen? It will just become off. It will just become what? Off. When you release, it will be what? One. When you press, it will just turn on. It will just what? Turn on. Again, you release and press, what will become? It will just turn off. Is this clear? Yeah, this will happen only one time. This will happen only what? One time. Okay, here what will happen? Task will happen only one time. That is edge triggering, because edge occurs only one time, right? Edge occurs only one time. Edge occurs only one time. Value changes from 1 to 0 only one time. So just TV will turn on. Just TV will turn on or turn off. Okay. So here what will happen, as long as value is 0, 0, 0, 0, volume keeps on increasing. Continuous task will happen. The task will happen continuously, then it is level triggering. You are doing the task only one time when the switch is pressed, then it is edge triggering. Only one time task, edge triggering. Okay, you are trying to do the task continuously, then it is level triggering. Is this clear? The difference between edge triggering and level triggering, is this clear? The volume button is example for what? Level triggering. What will happen in case of volume button? Continuously, as long as you press, there will be output. Okay, volume increases as long as you press. But TV power button, what will happen? Okay, TV power button means power button on the remote. You press it, but only one time TV will turn on. Only one time TV will turn on. And now it will not become on off, on off, on off. Understanding? Understanding the difference between edge triggering and the level triggering? Everyone, are you clear with what is edge triggering, what is level triggering? Yes, everyone, is this clear? Changing channels will be okay, edge triggering, because one time, right? It depends on that. Yeah. Now, if this is clear, let me ask you, what is this now? I'm pressing the key F. I'm pressing the key, okay, C. What is this? What triggering is this? What triggering is this? I'm pressing the key O. What triggering is this, everyone? Can you tell me what type of triggering is this? As long as I'm pressing the switch, I'm printing the things. What triggering is this? Yeah, continuous output is there. Continuous output is there. It is a level triggering. Level triggering, no. Continuous output is there. As long as I'm pressing it, there is a continuous output. Not one time. If it is one time, then it is edge triggering. Okay, it's nothing but what? Okay, level triggering. But when I press this key enter, okay, when I press this key enter, this is also level triggering only. Yeah, it's continuously okay happening. Yeah. In ATM, okay, in ATMs, when you enter the password, what type of triggering it will be there? When you enter the password in ATMs, when you go to the ATMs and enter the password, what type of triggering it will be? When you press the key only one time, password will get entered or multiple times? When you're entering the password in ATMs, when you enter the password in ATMs. Yeah, in ATMs, okay, you press one. Okay, will get, okay, you keep on pressing one. Will one get entered multiple times or only one time? When you press one continuously. Yeah. So if you are entering the password, what will happen? Only one time it will read it. Okay, one time. It is a nothing but edge triggering. That is nothing but what? Edge triggering. Are you clear? Entering password is what? Edge triggering. You press key once, one time only password will get entered. It's edge triggering. Clear everyone? Yeah. Are you clear with what is edge triggering? What is level triggering? So one time action is called as edge triggering. Continuous action is called as level triggering. So when you want continuous action, okay, when you want continuous action to be taken place, continuous event should be called, then it is called as level triggering. One time action is called as edge triggering. One time action is called edge triggering. Clear? Yeah. Then there is one more concept called bouncing effect. What is this bouncing effect means? Okay, have you used metal scale anytime? Have you used metal scale anytime? Yeah, if metal scale, what will happen when you hold it tight at one end and release it? What will happen? Assume you have a metal scale. On end, one end you will hold it tight. On the other end, you'll pull it down and release it. Other end, you pull it down and release it. What will happen? It will go back only one time or it will vibrate. On metal scale, you hold it tight at one end, other end you pull it down and release it. What will happen? Yeah, it will vibrate, right? It will vibrate. Okay. So same thing, what will happen here? Okay. When it comes to switches, right? Switches ideally what you should get when you press and when you release this is the ideal waveform you should get. This is the ideal waveform you should get. But because of the vibrations, what is happening in the case of switches means there is a metallic plate that vibrates. Okay. So usually what you have here circuit like this. This is your circuit, right? Yeah, this is your circuit. Okay, what will happen when you press the switch? It will connect it to ground. When you release, it will connect it to, okay, 5 volts. So you will get like this 1 0 1 0 1 0. This is ideal waveform. But what will happen? Okay, when it comes to this switch, right? The switch will be having a metallic plate. Okay, because of that metallic plate, if I show you, okay, if I show you, there is a metallic plate in the switch. So what will happen when you press and release, this metallic plate vibrates. This metallic plate what? Vibrates. See, when you press, it should make the contact like this. When you release, it should break the contact like this. It's making the contact and breaking the contact. But because of vibrations, what will happen? It will be vibrating between making the contact and breaking the contact. This switch, the metallic plate vibrates. Because of the vibrations, what will happen means, okay, your output will be something like this because of the vibrations. When you release, it will not just go back to 1, it vibrates between 1 0 1 0 1 0 and finally settle down to 1. Finally settle down to what? 1. This is 0, this is 1. Okay, till here things are clear. This is called bouncing effect. This is called bouncing effect. This is called what? Bouncing effect. Because of the metallic plate, what will happen? Okay, when you release the switch, you just doesn't go back one. Okay, when you release the switch, you doesn't go back one time. Okay, you will be what? Okay, it will be, okay, it will be making the contact, breaking the contact, making the contact and breaking the contact. And so there will be what? Vibrations, and finally it will become what? 1. Finally it will become what? 1. Is this clear, everyone? The bouncing effect. So this is all about bouncing effect. Okay. So what we have to do here is, okay, if there is bouncing effect, what will happen means you will not get a proper output. Okay, when you release the switch and press the switch, you will get multiple times the edges. When you get multiple times edges, what will happen? You'll get the output multiple times. You'll get the output multiple times. Example, what will happen? You press the switch one time. Instead of one edge, you'll get multiple edge. So if this was on your TV power button means when you press the switch, instead of TV turning on, it will turn on and turn off. It will turn on here, turn off here, and when you release also, it will turn on here, turn off here. It'll the events will happen multiple times. Events will happen what? Multiple times because of the bouncing effect. Okay. To remove the bouncing effect, what we can do is we can just use one software delay. We will just call one software delay. That is nothing but your for loop. You can use for loop to remove the bouncing effect. Okay, because when it is vibrating, we will not read anything. We will just ignore these values by calling a for loop. Okay. So this is all about, okay, introduction to the switch. Okay, introduction to the switches, then the way the switch can be connected, and on your board how it is connected, and the two triggering methods, edge triggering and level triggering, and the bouncing effect. Okay, this is done. Now what we can do is we can write a code. By knowing these all things, we can write a code. So what we will do is we will write a code. We will write a program to toggle the LED, to toggle the LED when the switch is pressed. When the switch is pressed. Okay, we'll try to toggle the LED when the switch is pressed. Okay, we'll write a program to toggle the LED when the switch is pressed. Okay, so for that what we'll be using means we'll be using LED that is connecting to, okay, port D. One LED we will use that is connecting to RD0 pin, and the switch what we will be using means we'll be using a switch, okay, connecting to port B, okay, which is connecting to RB0. Okay, this is our problem statement. What we will do, we'll write a program to toggle the LED when the switch is pressed. Okay, fine. So let us create a project for that one. Is the problem statement clear? Is the problem statement clear? Is the problem statement clear, everyone? Yeah. So if this is clear, what we will do is we'll try to write the code. What I will do is I'll open MPLab ID. Okay, MPLab ID I'm opening. We will write the code there for that problem statement. Okay, I'll close the old project. See how to close the old project means if you're running any project, right click on it and close it. Right click on it and close it. So I'll take your file, new project. Okay, I'll again check microchip standalone. Select your device. Pick 16F877A. Next. Then next. Then next. Then let it be on desktop only. I'll create it. Okay, I'll give the name as switch. I'll give the name as switch. Finish. Okay, I have created. Then I will add a main file here. Right click on the source file, new, and the main.c, and give the name as main. Finish. See, I'm going fast because yesterday I already showed you how to do this. Yeah, so here we have our code. So what is our problem statement? Okay, what we have to do is we have to, I'll just add a comment, write a program to toggle the LED, toggle the LED when the switch is pressed. When switch is pressed. Okay, write a program to toggle the LED when the switch is pressed. Okay, so what we have to do here is configuration. Okay, see, I'm using switch, I'm using LED. So both we have to configure. Okay, configure. Okay, switch pin and LED pin and LED pin. First, we will configure LED pin. Okay, so which pin I am planning to use? We are planning to use RD0 pin. LED we are going to use connecting to RD0. So I have to configure that RD0 as input or output. I have to configure RD0 as output. RD0 as output. Configure RD0 as what? Output. Okay, in order to configure RD0 as output, what I can assign here is, okay, see how we are having data direction register for, okay, port B, like that we have for tris D as well as. For port D, tris D is a data direction register. So we have to assign, to make the port D as output, we have to assign this, okay, register as 00. Okay, I'm using only one bit, right? So I'll be using tris D0 as 0. Tris D0 as 0. Okay, let me tell here. Port D is having 8 pins. What are the pins? RD7, RD6, RD, okay, 5, like that, 4, 3, 2, 1, and RD0. 8 pins are there. Okay, to configure those pins, we have tris D is the 7, 6, 5, 4, 3, 2, 1, 0. Okay. Okay, RD0 to RD7, TISD0 to TISD7. This is what we are having here. Okay, so now if I want to configure RD0 as output pin, I have to configure RD0 as output pin means TISD0 I have to assign it as a 0. Now to configure RD0 as output pin, we have to assign TISD0 as a 0. Okay, same way here switch. When it comes to switch, what is happening? This RB0 pin should be configured as input. Switches are input. Okay, switch is nothing but input. So we have to configure RB0 pin as input. Okay, so here TISD 0 equal to 0. Okay, to configure RD0 as output, then configure RB0 as input. Okay, to configure RB0 as input, what I have to assign? TISB0 as 1. TISB0 as what? 1. Clear? Input output, switches are input. Okay, LED is output. Switches are input. Okay, LEDs are output. Clear? This is initial configuration. Next, inside a while one, what I have to do is I have to check if the switch is pressed. If the switch is pressed, we have to toggle the LED. Detect the switch, press. After detecting the switch press, what we have to do is toggle the LED. Yeah. Now how to check if the switch is pressed or not? Here detect the switch press and toggle the LED. Okay. So we know that okay the switch is connecting to RB0 pin and it's a pull up. And here okay switch what we are using switch connecting to RB0 pin and it's a pull up. So it's a pull up means because it's a pull up, what will be happening when the switch is pressed? Switch is pressed, the value on the RB0 pin is 0. Value on the pin will be what? 0. When released, the RB0 pin will be 1 because it's a pull-up circuit. Correct? Yeah. So here what I can do here is I'll just put if RB0 equal to 0, okay, if switch is pressed, if RB0 equal to 0, okay, it means what? Switch is pressed, that I'm toggle the LED. RD0 equal to not of RD0. I'll add a for loop here. Okay, so let me brief out one more time. So what we are using is we are using the switch, okay, that is connecting to RB0 pin. We are using the switch that is connecting to the RB0 pin. We are using the LED that is connecting to RD0 pin. We are using LED that is connecting to RD0 pin. Nothing but this particular switch and this particular LED for programming. This particular switch and this particular LED we are using. Okay, so before using them, we have to configure it. So LED is output peripheral. So we have to configure RD0 as output pin. We have to configure RD0 as output pin. So for that, I have to assign TRISD0 as 0. Then we are using switch connecting to RB0 pin. RB0 pin. So what is happening? We have to configure RB0 as a input pin. So TRISD0 is equal to 1. Yeah, inside while one, what I have to do is I have to check if the switch is pressed. If RB0 equal to 0 means switch is pressed because it's a pull up. Okay, I'm checking if the switch is pressed. If it is it equal to 0, 0. If the switch is pressed, then I'm toggling the LED. RD0 equal to not of RD0. I'm trying to toggle the LED here and providing the delay so that I can see the toggling. So here what I'm checking. Okay, check if switch is pressed. Yes, if the switch is pressed, what we are doing? We are toggling the LED. Clear? Yeah. So let me clean and build. Okay, after cleaning and building, I'm going to load that here. Okay, file, loadx file. I'm going to desktop. Desktop only my code is there. Desktop. In the desktop, I have given the name as switches. Where is switches? Yeah, switch. Dist, default, production, and the hex file. I have loaded my hex file here. Ignore the other LEDs. I'm not taking care of them. Okay, ignore the other LEDs. Now, if I press this, first LED should toggle. You can see as long as I'm pressing, it's toggling. Once I release, it will stop toggling. If I press, it will toggle. If I release it, it should stop toggling. Press the switch, it should toggle. Once I release, it should stop toggling. Toggle. Once I release, it should stop toggling. Is this clear? Yeah, you can see this is my code. This is your output. If I'm pressing the switch, it's toggling. If I release, it will stop toggling. You don't worry about other LEDs. We have not written code for that one, so nothing will happen here. We have not written code for other LEDs. You don't worry about it. We have written code for this switch, this LED. So you can see if I press this switch, this LED will toggle. If I release, it will stop toggling. This is what I have written the code for. Okay, if switch is pressed, toggle the LED. Why RD0 is equal to not of RD0 means? Okay, RD0 is equal to not of RD0. This is nothing but what? It will toggle the state of the LED, right? Assume initially what? Initially what? RD0 is 1. You come back, it will become not of 1 is 0. Then not of 0 is 1. Like this, it will keep on changing the state of the LED. Initially, if it is 1, it will become 0. Later, it will become 1. Later, it will become 0. Later, it will become what? 1. Every time, it will toggle the state. 1 will become 0, 0 will become 1. 1 will become 0, 0 will become 1 whenever the condition is true. Understood why? Okay, now here someone is asking what happens if I increase this 50,000 value. It will toggle slowly. It will toggle what? Slowly. If I want, what I will do, I'll add one more for loop here. It will toggle what? Slowly. Instead of toggling faster, it will toggle slowly. Okay, I'll add here clean and build. You can see it's toggling slowly. Instead of toggling faster, if I add more delay, it will toggle slowly. It will toggle slowly. Okay, Pooja is asking how to load multiple X file. You cannot load multiple X file, only one file at a time. One code will run in your microcontroller at a time. You cannot load multiple code into your microcontroller. Microcontroller will do only one work at a time. Okay, you want the code. Okay, I'm sharing the code in the chat box. Yeah, I have shared the question code in the chat box. You can get it there. Okay, fine. We'll stop here for today. You complete this. We'll see. Okay, this is level triggering. We'll see the edge triggering in Monday's class. Tomorrow you don't have class. We'll meet on Monday. Okay, fine. Good night, everyone. Thank you. I have shared the code in the chat box. You can check that area. If your code is not working, I have shared in the chat box. You can try that code area. Gauri, to clean and build, right click here, clean and build. Right click on the project, clean and build. Yes. Good night, everyone. Thank you and good night. Okay, we will see the things again in the Monday's class. Till Monday, please try to work on LED, work on switches. Till Monday, please try to work on LED and work on the switches.